के अंदर 6:35 पे।
ओके।
डॉक्टर स्मिता जी आप स्टार्ट करिए।
Okay. Knowledge is power. Sharing knowledge is the key to unlocking that power. Good evening to all. My name is Dr. Smita Agrawal, the host for this meeting. And today we are honored to welcome our esteemed guest, Dr. Sudhakar Pandey sir, who have taken the time to join us this evening. Dr. Sudhakar Pandey, he was born in the state of Uttar Pradesh and completed his PhD in horticulture vegetable science. Currently, he was working as Assistant Director General in Horticulture Science, ICAR, New Delhi. In span of 23 years of research experience, he developed 18 cucurbitaceous vegetable varieties and hybrids, and also developed the first hermaphrodite rich gourd variety, that is Kashi Khushi. The extensive research work helped him to identify new genes and SSR markers in cucumber, along with developing certain special varieties which are registered with NDPGR. For the tremendous contribution to the agriculture science, Dr. Sudhakar Pandey have been awarded with numerous awards and accolades, such as ICAR Award for the Team Research for the Biennium 2006, Dr. Kirti Singh Gold Medal, Indian Academy of Horticultural Science, New Delhi 2021, Distinguished Agricultural Scientist Award by UP Academy of Agriculture Sciences, Lucknow 2019, Dr. Kirti Singh Lifetime Achievement Award, Indian Society of Vegetable Science, Varanasi 2019. He is a fellow member of National Academy of Agricultural Sciences, New Delhi 2018, and the Recognition Award for PPV and FRA, Ministry of Agricultural Sciences and Farmers Welfare, Government of India 2017. He is also a member of the Task Force for Development of DOS Testing Guidelines. And the list goes long, but the recognitions received by Dr. Pandey are an inspiration for many young scientists and research scholars. With such an astonishing experience, today, Dr. Sudhakar sir will be sharing with us his knowledge on demand-driven vegetable breeding, opportunities and challenges. Passing the mic to you, sir.
Thank you. Can you tell a little bit about who is audience with us, for whom we are going to be deliver this talk?
Ideal, Dr. KL Chadda साहब.
No. Who is audience for that today talk is?
अच्छा,
Our
audience
voice is clear.
अच्छा, audience sir,
Audience, yeah,
BSc,
audience.
BSc, MSc, PhD, असिस्टेंट प्रोफेसर, एसोसिएट प्रोफेसर, प्रोफेसर, डीन डायरेक्टर, ऐसे लेवल के लोग हैं सर।
Okay. Thank you very much. Thank you, Smita, for your very nice introduction.
Thank you so much.
So today I have to be discussed a little bit about what presently, particularly in vegetable breeding aspects, what are the demand, particularly what are the new area where we have to be do breeding program. So as all of you know that in our horticulture division, little bit I will tell about the ICR, what we are doing in our horticulture science division at ICR level. So just for introduction, we are dealing with near about 210 crops as a horticulture as a whole by 23 research institutions that are being undertaking this research work with the help of 13 AICRP. And the crops which we are dealing, that include the fruits, plantation crop, flowers, that include dry flowers and vegetables, spices. In vegetables, we are including the tuber crops as well as potato and mushroom as well as medicinal crops. So including all, we are at horticulture division, we are working 2010 vegetable crops. So if we see that in Indian horticulture, that we are calling as a science-led golden revolution. So in the world, we are second largest producer of the horticultural crops, which are contributing near about 12% of total fruits and vegetables to the global food baskets. And we are contributing near about 33% of total agriculture GDP through our horticultural crops. If we see that in 1951, we grown commercially 25 crops, but at present, if we take the data of 21 and 22, now we are working on 210 crops. So our diversification of the crops, particularly horticulture, is very high. And if we compare in 1951, we have less than 25 improved varieties, but at present in our horticulture division, we develop more than 2,500 improved cultivars, including all horticultural crops. And production that is near about, that was 25 million tons, and presently we are producing 347 million tons, and we surpassed the total food grain production of our country last many years. So this is one of the, I think, as a horticulturist, we can take a pride of that. Now we are producing more than the food crops. The total, if we see the export of particularly fruits and vegetables, that was nil when we were independent. Then after that, now we are near about exporting 3,688 million US dollar, particularly for export, which include the fresh as well as the processed product. So overall, in horticulture, we are have the crop diversification, and which is leading for nutritional and livelihood security. And also this is enhancing farmers' income. So if we are talking about the doubling of farmers' income, so certainly our horticultural crops, they are playing from the fronts. So that is also one of the important aspects of our horticulture crops. Among cultural crops, we see the vegetables. In contribution of the vegetable in total horticulture production is about 60%. If we see the area and production, near about 4-fold area and near about 12-fold in production, we have increased since 1951, and productivity also near about 3.17-fold. At present, productivity is 18.1 tons per hectare, and per capita availability, if we see in 1951 it was 88 gram, now we have near about 300 gram per capita, which is also has been increased near about 4-fold. But if we see the nutrition expert group report 2020, they were recommended near about 400 gram vegetables per day. So if we consider 400 vegetables per day for per capita. So near about 18% of Indian do not meet these recommendations. Although we are contributing in our area near about 14% and in production also near about 14%. And what target we have? Near by 2047, we need to enhance our vegetable productivity just double. Now we have 18 tons per hectare. It has to be 36.09 tons per hectare to fulfill the projected vegetable demand of the country, particularly when we have to be recommending 400 gram vegetables per day. So if we see the vegetable research infrastructure, particularly in our 1941, we have started 49, we have established the vegetable breeding at Katran in Kullu Value. Later that has been transferred to the ICAR New Delhi during 1955. Then 1956 Division of Horticulture that has been started in ICAR IARI. Again in 1967 IHR has been stabilized in Bengaluru. Then 1971, our very important research program, that is All India Coordinated Research Program on Vegetable Crops, that has been initiated at IARI New Delhi itself for multi-location testing of promising genotype across the country. Then in 1966, we have started the Project Directorate of Vegetable Research that was called PDVR at IARI New Delhi, and after sometime in 1992, that has been shifted into the Varanasi. And in 1999, due to importance of vegetable crops, that PDVR has been upgraded to the ICR, Indian Institute of Vegetable Research, with focus towards research on 20 major and 22 underutilized vegetable crops. So presently, we have a national institute at Varanasi with the name of Indian Institute of Vegetable Research, which is coordinating and contributing a lot for vegetable research for our country, particularly in research as well as policy making. So if we see, vegetable is a very big group. And now presently we are having more than 100 type of vegetables in which we are doing little bit research, either in some ICR institute, otherwise in agriculture university. And out of that, 18 and 22 crops are highly researched, where we have a good number of varieties, good number of production technology, process technology. So other crops, we have to prioritize their research program, and we have to invest on that program so we can get the more diversified. So other are our future priority, other crops are our future priority. And development of the high yielding varieties was the major breeding objective to increase the per capita availability of the vegetables, which have been achieved at some level. Particularly productivity we have increased, but what are the demand of the market, we have to focus on that. So quality in vegetable crops in contrast to field crops, because we have to be focused in our talk, that will be mostly on the consumer demand as well as the market demand. So if we compare with the field crops, so quality of vegetable and breeding aspects of vegetable is entirely different. And we cannot compare vegetable breeding with other crops like cereals. In vegetables, if cultivated variety will be accepted by the market, only then growers can get the better price. Otherwise, it is very difficult. If we don't have good shape, good size, good color, good appearance, then nobody will buy the product of the farmers. In other crops, MSP is there and farmers can sell their produce on the MSP to government. But in vegetables, we have, based on our product, we can sell the product because we don't have MSP. So that is our also a challenge before us. Therefore, the role of breeding is very important in case of the vegetable crops. So development of the better variety is providing. Why we have to go for better varieties? Why we have to go for the variety which is based on the market demand? Because we have to have the greater food security, lower rate of malnutrition, because vegetables is playing a lot of to reduce the malnutrition as well as the food security also, and lower food cost. We have like tuber crops, potato, these are the lower food costs. In the less number of price, we can get the more number of calories. So more food choice also. We are, as you know, we are working in the several crops. So we have more food choice and safer foods for consumers. Enhance the income generation for the farmers and other stakeholders. So who are deciding the market demand? If we see where we are getting the demand, particularly for our vegetable breeding. So these are the three key holders particularly. One is consumer, what consumer need. Suppose we are consumer, you are consumer, whether they are utilizing fresh or processed, whether any food any vegetables we are taking as a fresh and otherwise processed. So we are the deciding factors. When we are going in the market, we don't see how much farmers taken from yield from one plants. We are generally looking the quality of the produce. If any bottle gourd is very long, very big, very wide in the shape, so we are not preferring that. If it is very uniform, green, attractive in color, we are preferring. Whether farmers are getting 1 kg from a plant or 2 kg, we are not bothered. And then our other other demand, we can say farmers are other client for our vegetable breeders, growers and traders. What farmers need? Farmers need, they need such a variety which can be grown with the low cost of cultivations, like disease resistance. They have to climate resistant, biotic resistant, abiotic from different diseases. So farmer choice is different, and in the same time they need high yield varieties also. And our other client are industry. What they need processing quality, they need value addition. So these are the three main client, particularly in the market. A consumer, as we are a consumer, and then farmers, traders, and industry. They are the making demand, and based on their demand, we have to design our product. So if we see the consumer delight, so yield not seen by the consumers. Already we have discussed in the earlier slide. They need quality product and safer to health. One segment of the society, as we know, they are high paid. So they are ready to pay any cost of the safe produce. Indian organic market is growing at the rate of 3 times per year. So if we have the organic produce, we can get any price from the market. So these are the some area, these are the consumers which have the lot of choice. So consumer value product appealing to eye and easy to carry, safe and healthy, hence yield become lesser importance for them. Already we have discussed in the earlier slide. So the consumer are not bothered about the yield. They are bothered only about the safe and healthy produce, which is very attractive for the eye and easy to carry their home. So what should be objective of the breeding based on these users? Who are our users? Already we have discussed: consumer, growers, farmers, then processing industry. So what are the consumer objectives? What consumer want? Consumer want good taste. They want good flavors. They want good appearance, and which indicates by color, shape, and size. In cereal crops, particularly wheat, there is no differences in lot of differences in color. There is no differences in shape. But in vegetable, even a single crop, we have lot of color, lot of shapes. So these are the quality parameters, and same time shelf life, nutrition value, and safer to health. Yield doesn't have any meaning for the consumers. And then other objective, what we have to decide, that is for growers or farmers. What growers need? Growers or farmers need good yield, resistant to important diseases and pests, uniformity, and abiotic stress resistance, particularly moisture, flood, or high temperature, whatever may be. And for processing industry or value-added industry, what they need? They need the resilience to transport. It is very easy to transport. Then suitability as a raw material, particularly flash thickness, TSS, seed arrangement, flash recovery, color retention, and oleoresin contain, color extraction, so on. Lot of parameters are there, particularly based on the use of the industry. That parameter can be decided. So here our responsibility as a researcher, research personnels, we have to be deliver the desired product based on the industry demand, based on the farmers demand, based on the consumer demands. So major breeding area in vegetable crops based on the previous slides what we have seen. So here we will in our these talk we will cover the breeding for quality, particularly appearance, taste, these type of parameters that will be discussed in this segments, and breeding for disease and pest resistant to get the safe product for health and also tolerant to abiotic stress. then breeding for nutrition quality, and breeding for post-harvest state processing and value addition. So on these parameters, we will concentrate in our talk, and I will try to finish our talk within a time. So just a minute. So breeding for quality, which we are called the consumer preference. So each and every vegetable crop had different segment for the market. In the next slide, we will show how we have defined the segments. And the consumer are seeking new eating experience, different quality attributes, and improved convenience. Plant breeding for improved taste, convenience, and consumer appeal, such as color, shape, and size, are the main objective, particularly for consumer preference. If we add these attributes and develop the product, certainly it will increase per capita vegetable consumptions. So some crops we will discuss what attributes we have. Besides, this is based on the quality, appearance, shape, and size. So if even in tomato, if we see, we have 10 market segments globally based on the different categories. For example, we have the beef stick tomato, Roman type tomato, are called wine ripe tomato, cocktail tomato on wine, tiny plum tomato, mini plum tomato, red cherry tomato on wine, attractive yellow and orange cherry tomato, mini San Marzano type tomato, tear drop and pear shaped tomato, super or premium taste tomato. Taste is also, these are the based on the shape and size. We have different type of segments in the market, particularly in one crop we can see. So based on the demand, we have to be design our product. So when we are starting the breeding program, we have to be, before starting our breeding program, we have to design our profile, product profile. For product profile, you have to consider each and every traits, particularly it may be your quality traits, it may be your resistant trait. Based on that, if first we will decide the profile of that particular product, then we have to start our breeding program. Taste is also concerned in tomato, particularly acidity. Generally, in many meetings, people are saying that old tomato, hybrid tomato, they don't have any acidity. So now we have started, we have make a cutoff that any tomato variety that cannot be released if it doesn't have this much acidity. So based on that cutoff, we are now recommending the any tomato varieties. Here you can see that is just an example. I am showing 2 to 3 crops, just example. In pumpkin, you can see the different shape, flat round, round to oval, oval to oblong. You can see these type of segments in the market, which are preferable at which area we have to breed our variety accordingly. And then based on the rind color, you can see this is a mottle green, then some varieties are dark green, some are light green. So, and by size, if we decide our segment, then is small fruit, medium fruit, large fruit, very large fruit. Here you can see less than 3. So based on that, we have the, only in pumpkin, you can see, we have to decide our product by fruit shape, by rind color, by fruit size. So as a breeder, we have to see the market, which market is leading. On that basis, we have to decide the profile of our product. Accordingly, we have to grow for our breeding program. Similarly, in watermelon, this is also example. Icebox type, nowadays it is very popular. Then sugar baby type, it was earlier. Then again Jubilee type. Now Icebox and Jubilee type both are now gaining momentum in different places. Then Crimson Sweet and Charleston Gray. So these are the different segments based on their color and their shape and size. So we have to decide in some places, still Jubilee type is very demanding. And some places, particularly in our area, Icebox type is. Why these preference has been changed? This is only because due to the nuclear family, sometime due to the taste, sometime due to the other preference. So these segments are changing. Similarly, in bitter gourd also, we can see different type of fruits. We can see in the shape and color also. So accordingly, we have to decide these white lung that is very popular in Tripura area. So when these very popular in Kerala also. So accordingly, we have to be decide our product. Similarly, in carrot, we have to decide our carrot breeding. So now baby carrot. What is the baby carrot? That is generally used as a salad without cutting. There is no need to cut it. We have to bite it and can be consumed in 1 or 2 bites. Just like these guava and other things generally we are eating. Similarly, there is no need to cut as a salad. Directly we can bite. So this is baby carrot. New segments are coming. Other segments already we know. And rainbow carrots. Rainbow carrots, that is super sweet and crunchy, multi-pigmented roots that has been. So this is we are calling the rainbow carrots. So these are the different segments. Just example I have seen, vegetable is a very big group. It is very difficult to cover in 1 hour all quality parameters for all vegetables. Similarly in brinjal, shape and color, both are very different. Even when we go, even in Uttar Pradesh, Eastern Uttar Pradesh, we are generally having the different color preference. When you will come in the Jhansi area, then your color preference will be entirely different. When you will go in Maharashtra, they are liking the variegated colors. So based on the area, we have a choice. So these are we are not going to read these slides. So here we have enumerated the crops and what should be the different important traits which we have to consider when we are going for the breeding programs, particularly vegetable pea, French bean, cauliflower, cabbage, turnip, carrot, radish, beetroot, onion, spinach, beet, tomato, potato, brinjal, chili, bell pepper, okra, almost all crops, major crops I have given in these slides. So that can be taken into consideration when we are going to have the breeding for quality parameters. And next parameters is what we have, that is disease resistance and pest resistance. Why it is important? It is important for 2 purposes. One is consumer need safe produce, and if we have a resistant varieties, so farmers need not to spray so much, so the cost of cultivation also can be minimized. And same time, we have to disease and pest resistant. Again, we have to tolerant to abiotic stress also, particularly moisture, temperature. If we have to, these are the also demand by the farmers, demand by the industry. So consumer they don't whether these variety, these particular market, if we have any produce, whether it is from resistant variety, that consumer cannot be defined. But farmers, they can know this is the resistant variety because they are the real growers and they are having the problems of disease and pest. Therefore, these objectives basically for the farmers. So development of the resistant varieties and hybrids will fulfill the objectives of both consumer and growers, as it provides the safe vegetables and also reduce the cultivation cost. In our system, particularly ICRP systems, we have developed 60 resistant varieties that are tolerant, particularly leaf curl virus and bacterial built in tomato, yellow vein mosaic virus and innocent leaf curl virus in okra, powdery mildew in pea, bacterial built in brinjal, downy mildew and CGMB resistant in muskmelon. That has been already developed. And we are always in the process in multi-location testing, and several other universities also, they are developing the resistant varieties. The data which we are showing, that is from the All India Coordinated Improvement Vegetable projects. So some examples we can see here, tomato Arka Rakshak and Arka Abhed. These 2 varieties that is having the multiple disease resistance from tomato leaf curl virus, bacterial built and early blight, Kasi Aman, Kasi Adarsh and Kasi Chan, that has the tomato leaf curl virus TY3 resistance genes that has been developed by the IAVR, and upper 2 variety, previous 2 variety that has been developed by the IHR Bengaluru. In Chile, we have developed the Arca Meghna, that is chili vanillin virus resistant and the powdery mildew resistant. It also has the 2 disease resistance. Then in okra, Kasi Pragati, Kasi Kranti, Kasi Sadhari, these are the resistant to YBMB and OELCB. In brinjal, bacterial wilt is a most important problem, particularly for South India as well as our eastern, particularly from Ranchi onwards, Odisha and our hilly areas. So now in that area, if any variety don't have bacterial wilt resistance, that cannot be grown. So we have a lot of bacterial wilt resistant variety in Zanplan. So one of the most important variety that is Swarna Samli. And in P. Kasi Mukti, that is powdery mildew resistant. Other varieties are also there. Just for example, I have given few varieties. In case of resistance, particularly if we are trying to F1 hybrid development, we have to target the monogenic and dominant traits, because these traits, if it is monogenic and dominant, we can combine several traits in one hybrids. So that is most important. If any trait that is governed by the recessive gene action, so it is very difficult to express in the FR, or through selections we have to go. And when we are talking about the disease resistance, wild species are good source of resistance genes, and molecular assisted breeding help to mapping of genes on different chromosomes. That is also very important. We have to use the wild species, and how we have to integrate that, we can use the molecular assisted breeding program. The TY genes, particularly for tomato leaf curl virus resistance, that has been introduced from the wild species, that is Solanum chilens and Habrochates. So you can see the importance of our wild species. And these two species, these all TY genes, now we have TY1, TY2, TY3, TY4, and TY5, that has been integrated in the different tomato cultivars. And it is most devastating disease when we are calling about tomato. So as you know that TY1 gene that is linked on chromosome number 3, chromosome number 6, and these TY2 on chromosome number 11, and TY4 on chromosome number 3, and TY5 on chromosome number 4. So already these genes have been mapped, and that has been transferred from the wild derivatives. Similarly, mapping for disease resistance was done for powdery mildew, downy mildew, and anthracnose in case of cucumber. And similar studies going on in other crops also. So here, some examples I have shown that resistant breeding, particularly in tomato, how we have developed that using the marker assist selections, and we have developed the Kasi-Am and Kasi Adarsh and Kasi Amul. And these are the programs how we have to be use the donor species as well, and we are our recipient species, how we are using these different cross different families, how we can go and how we can when you have the resistant breeding, you have to be this type of symptoms. This is very important, because at least that disease incidence should come, then you can decide that this is the resistant. So it is not so easy. It is very tedious methods. So, and here gene pyramiding for triple disease resistance in tomato, that is already going on. Now we have at F5 stage. Here generally that institute is targeting tomato leaf curl virus as well as root knot nematode, that is governed by the MI genes, and late blight PS2 and PS3 genes. So this breeding program is going on very successfully using the marker resection as well as the phenotypic basis. Generally, we are proceeding for this, and because it is in F5 stage, I think within 2 years we have a triple resistant, particularly for nematode, which is one of the most important pest for the tomato. Similarly, here also development of interspecific hybrids through embryo rescue for heat stable nematode resistance, MI9 genes for Solanum arcanum. Here also we are using the wild species, particularly transfer the different nematode resistant MI9 genes. So these are the some examples which I would like to show. I am not discussing all these detail. I would like to share the slides after my presentation. So if anyone have any questions, otherwise they can read on the slides and they can understand that. And one very successful example, that is Arka Samrat and Arka Ratchak, that has triple resistant and it has a bumper yield with high yield that has been developed from the IHR. And similarly, Arcavhe, that is multiple disease resistant tomato, has bacterial wilt resistant, early blight, and TULCB and late blight. 4 disease they have combined in one particular genotype. So, and yield potential you can see 75 to 70 to 75 tons in 140 to 150 days, and this is suitable for Kharif as well as Rabi season. So by single variety we can save a lot of money, particularly in terms of application of pesticide, and we have good yield also by these varieties. So these are the, I think, boon for these varieties are the boon for the farmers, not only for IHR area, for whole country. So if we see what are the yield losses, particularly when if you have such type of disease, so here pest and disease both we have here we have given in this table, and you can see particularly in some crops 98%, 80%, lot of losses due to these diseases. I'm not reading each and every, but here you can see in case of brinjal 60% only from Formosus blight, and Fusarium wilt near about last 10% loss in our area in where bacterial wilt loss, this fungal wilt is not very common. And in other crops also you can see particularly in okra, yellow vein mosaic virus, it is causing near about 70%. Leaf blight in legume crops, that is 60%. So lot of losses due to only disease. Losses means we are growing the crops, but ultimately we are not getting the good quality produce. We are not getting our potential yield. So these losses, they are converting in our losses of income of the farmers. So when we have already known diseases, in the same times lot of new diseases are also emerging. So we have to be taken into consideration these diseases. Some examples I have put here, like blossom blight in case of cucurbits, bacterial wilt and angular leaf spot. Earlier that 2 diseases that has not been reported in cucurbits, but now near about 10% losses that has been reported in these crops. Similarly, cucurbit aphid-borne yellow virus, 46% that disease is occurring in some areas. Tomato leaf curl New Delhi virus, 20 to 47%. Earlier it was basically tomato disease, but most of the cucurbits now they are being infecting by this particular virus. And Jukni yellow mosaic virus in Uttar Pradesh, the maximum percent of vector-borne viral incidence was recorded for Begmo virus, that is near about 99%, followed by the Poti virus, which is 39%, and Tobamo virus, that is 38% in cucurbits crop. And incidence of Begmo virus that was not reported till date in sponge gourd, but now first time it has been observed in sponge gourd also. So these are the diseases we are generally calling emergence of new diseases. So we have to be focused on this type of diseases. Otherwise, because we have to make our plan, particularly for breeding and other aspects. Otherwise, we will not make that timely release of any varieties particularly. Here, what are the major factors which are causing these emergence of new diseases? Introduction of new materials, particularly if see 56% are diseases only coming due to if we do not have good quality quarantine facilities, and we are getting some disease material from foreign country, so we are getting always new diseases. That is, so we have to be very cautious when we are introducing any material from. And virus and fungus as alone, they are causing near about 77% emergence of new diseases. So virus is a major threat, followed by the fungus. So these two, we have to always keep our eye on these 2 types of causal organisms, particularly when we are talking about the emergence and pre-emergence of diseases. Here we can see these are some new pests that has been earlier, they have been not reported in any crops, like melon weevil. About 70 to 80% fruit and 30% fruits were damaged by this weevil, particularly in sponge gourd. It was very difficult to identify generally our growing tips, they are drying, and it is very difficult to identify. In the photographs we can see, but in the naked eye it is very difficult. We have to go very close, then we can see these type of white plum moth. Particularly these pests damage the leaves and buds of the bottle gourd, and damage is severe when they feed on the emerging buds, resulting in the restricted growth of the bud. Bottle gourd mirid bugs. Here you can see that previously reported, but now they are becoming the major pest of these crops. Around 40 to 60% leaves and up to 80% fruit are infected by these bugs. Papaya mealybug. These are some mealybugs. They become the major pest in some times. And mites, serpentine leaf miners, tomato leaf miner, Tuta absoluta. Already this was the 2 to 3 years back. That was the major pest, particularly for tomato. And like black thrips, last 2 years, now we have the little bit management practices, particularly black thrips. Earlier 2 to 3 years before, it was a major pest for the chili, and most of the crop that has been devastated, particularly in Lama and Andhra area, that is only due to the black thrip that came first time. So insect resistant, that is very difficult because this is very complex. Aphid, whitefly, thrips, and leaf hoppers are very important because they vectors many viruses. Sucking pests are major threat for crops grown under protected condition, and sometimes it found difficult to manage them. Therefore, and breeding for these particularly insect, that is very difficult. So solution for these were targeted by starting the research on development of the transgenes. And some works that are already going on, some already we have result with us, particularly RNI in okra against yellow vein mosaic virus. The cry genes against Leptotrans in eggplant, tomato, and okra. That work is already going on, and it is on very advanced stage. Virus resistance in watermelon and tomato. DBM resistant with cry genes in cauliflower and cabbage. Aphid resistant in brassica. Herbicide resistant in onion. Fruit and shoot borer control through RNI. Delayed fruit ripening in tomato. These are some transgenic. Some results already we have with us, successful results, and some already under the process. So these are the some already we have discussed the disease and insect pests, some abiotic stress tolerance, specific traits, and already we have some achievement, particularly in tomato. For high temperature, we have developed 2 varieties, that is Kasi Tapas and Kasi Adbhut. Similarly, for brinjal, frost resistant, that is Kalyanpur 202-9. In cauliflower, high temperature along with humid, all early these early cultivars, particularly which we are calling the tropical type of cauliflower, they are generally high temperature tolerant lines. High temperature and along with the dry conditions, these are the some genotypes already we have identified, particularly for this state. Similarly, in carrot, high temperature and for high humidity, Pusa vrishti, that is one variety that has been identified. For radish, high tolerant along with dry condition, Kasi Rituraj, one radish has been identified. Similarly, in other crops also, we have some varieties, particularly for abiotic stress tolerance, particularly high temperature, low temperature, or hot heat tolerance. Here you can see these are the 2 varieties that has been developed for high temperature. That is, one is Kasi Adbhut and other one is Kasi Tapas. Generally in tomato, all we know that it is very difficult to set a fruit when temperature goes more than 32, day temperature and night temperature when goes more than 28, something like that. And then here we can see that day temperature, these 2 varieties, they have fruit set up to 40 degrees Celsius plus minus 2 degree, and night temperature 32 plus minus 2 degree. They have the capability to set these quality fruits. So these 2 varieties that has been already recommended, and that has been recommended by the Central Variety Release Committee and notified by the Government of India for cultivations. Similarly, in case of our radish, we have a heat tolerant variety, that is Kasi Rituraj. Here you can see in the month of May, here in the first week of June, this is the farmer's field, and marketable we can get with this variety, that is 350 to 650 quintals per hectare, and this is suitable for summer, autumn, spring and winter season cultivation. So this is one of the variety that has the heat tolerance temperature up to 38 to 43 degrees Celsius. Similarly, Kasi Varamati, this is another variety, spinach beet variety, which has the tolerance up to 30 to 40 degrees centigrade during April to June. And you can see this is the field view in the month of May. This is field view in the month of June. This is field view in the month of June and July. And it has suitable round the year. We can say these varieties suitable for and delayed bolting. That is one of the important things. Only due to the bolting, generally we do not have the good quality, particularly when we have the high temperature. So these can delay the bolting by 16 to 33 days. So these varieties can be used when we have in high temperature conditions. Similarly, Kasi Adra, that is one of the radish variety. It also has the tolerance to moderate temperature, 30 to 35 degree, and have the good yield potential. Similarly, we are working in some place at IAVR for flood tolerance. So here, generally one Kasi Aman, that is tomato that has been grafted on the brinjal root stock, and that was able to tolerate. Here you can see this is a totally flooded field, and that particular genotype that has been grafted on the brinjal root stock, it has 48 hours waterlogging stress during early vegetative stage in August and September, and near about 96 hours during reproductive stage in November and month if we have occasional these rains. So we can have this type of genotype with us, particularly using the graft, that is a brinjal root stock graft. So we can say that this is a flood resistant root stock. So another objective what we have discussed, that is the breeding for nutritional quality. Nutritional quality is very important. We have a lot of malnutrition with us. So when we are talking about the food security, similarly, we have to now have the more emphasis of our government that we have to be the nutritional security also. So when we are talking the nutritional quality breeding aspects, so only breeder cannot do this. So this is the multidisciplinary approach. Plant breeders, nutritional scientists, as well as the soil scientists also. If soil scientists are not there, then it is very difficult, because a lot of the trace elements, they are found in the soil. So we have to take into consideration when we are analyzing our product. So that therefore we have to be a soil science in our team also. We have the good genetic variability, particularly for minerals, vitamins, and phytochemicals in our germ plant. So therefore we can go for the nutritional quality breeding. So major goals when we are talking the nutritional quality, that is provitamin A, carotenoids, more antioxidant activities, good in iron and zinc, and rich in vitamin C and nutraceutical compounds. Also, we have to take into consideration these particular traits when we are talking about the nutritional quality. So these are some nutritional rich tomato. In tomato, high beta carotene, orange cherry tomato breeding lines have been bred utilizing B genes from wild species, that is Solanum hirsutum. These B genes shift tomato carotenoids accumulation from lycopene almost entirely to beta carotene and results in orange fruit color. So this type of, here you can say this is high beta carotene line, and in cherry tomato that has been transferred, and lycopene is 4.29 milligram per gram and beta carotene is 1.1 milligram per gram. And that genotype also has the beta carotene, that is orange color, has more beta carotene, that is 3.19 milligram, and lycopene is 0.76 milligram. So we have both type of lines and both type of varieties that has good lycopene, as well as same time we have a good carotene with good yield potential also. Similarly, in carrot, we have lot of pigment content in roots, particularly in tropical carrot. It was earlier, we were thinking that only we have to, in temperate carrot, we have this type of quality. But now in tropical carrot, which is very easily can be grown in our country. We have lot of pigments. Here you can see in orange carrots, we have good beta carotene content. In red carrot, we have good lycopene as well as beta carotene. In yellow carrots, we have a lutein that is very important. That is very medicinal compound. So that also we have in our yellow carrot. Similarly, in black carrot, we have anthocyanin, and in rainbow carrots, we have all anthocyanin, lycopene, and beta carotene. Therefore, for quality also, we have discussed that we have to develop the rainbow carrot, particularly in our breeding aspect. That should be our objectives. Anthocyanin-rich black carrot cultivars that has been developed, 3 cultivars in India. You can see the photographs that is totally black beauty that has been developed from PU Ludhiana, Punjab. Pusa Sita that has been developed by IRI New Delhi, and Kasi Krishna that has been developed. And for Kasi Krishna, we have the preclinical trial also, and that has the ability to reduce the this sugar also. So we have a preclinical data with these Kasi Krishna, but we do not have the clinical trial particularly. So let us see if we have the good data, we can do the clinical trial also. So okra variety Kasi Lalma, all you know that this is a very nutritious and tasty. It is very rich in anthocyanin, and now it is gaining a lot of popularity among the growers, particularly in kitchen gardens and commercial growers also. And Pusa Beta Kesari, that is very rich in beta carotene, that has been developed from the IRI. Similarly, in potato also we have biofortified varieties that is better for better health and nutrition. Kupri Manik, it is very rich in zinc and iron. Similarly, Kupri Nilkant, that is purple skin color variety, it is very rich in carotenoid and anthocyanin. And we are both variety that can be used as a table purpose. So these type of varieties now they are getting popularity among the farmers and consumers also. Similarly, we have biofortified variety in sweet potato also. Bhu Sona and Bhu Krishna. These two variety, these are, one is purple plus, another is orange plus. One is Bhu Sona is very rich in beta carotene, and purple plus variety, that Bhu Krishna, that is very rich in anthocyanin. If we are consuming one boiled sweet potato, we are getting 125 gram. That will provide full recommended dose of vitamin A, particularly for our children and pregnant women. If we are taking one sweet potato, particularly in a day, boiled sweet potato. So, but in nutrition quality, if we are talking, so we have to be generally these nutritional aspects, how we have to be make the aware to our consumers, because if we are not advocating that this particular variety has this type of nutritional quality, so these our consumer, they don't know. Therefore, particularly in yellow or orange tomato, if you see, earlier it was not a liking. When you will keep in market that one bucket yellow tomato, another bucket of the red tomato, people will try to take the red tomato only. They don't know that these yellow or orange tomato has good lycopene, which is very good for the which is very good for the cancers, or we are calling it as anti-cancer. So we have to be make the awareness among the consumers, particularly to make the different trainings program or through different campaign. We have to say that this our product, they are very good. So they are now, the orange color tomato, they got the acceptance in the supermarket, and now they are getting the good price. Acceptance to the consumer. There is need to aware the consumer for nutritional quality of the product, and should be available at moderate price. That is also very important. It will help to increase the consumption and also provide the better price to the growers. So we have to make the aware when we are developing the nutritional quality. So next objective, what we have targeted, we are discussing, that is breeding for post-harvest state and exports. That is also very important. We generally, for our export quality, we don't have a breeding program in our country, but nowadays we have started. We have decided the profiles, we have decided the export quality, what are the export parameters, what are the export rates, particularly for which country. Accordingly, we have to decide. And And in general, if we are talking, the main traits for post-harvest breeding is the transport quality. How we can have the product which have better transport quality, particularly how we have to the fruit shape, what should be the size that may be fit for the packaging. So hard rind thickness in watermelon, that is one of the, when we are exporting in the truck. So we are generally considering that if that variety had the hard rind thickness, so that have the better export quality, better transport quality. State fruit shape in bottle guard. So at least based on that, now we are trying to breed our varieties. And other crops also, state fruit is very important. And similarly, state fruit is carrot and radish also. If that we don't have state fruit, then there is chance to have the cracking in the roots, as well as have breaking is also in case of the carrot and radish. Even in bottle gourd also a lot of bruises is there when we are having the truckloads. And shelf life, more, if we have more in dry matter and less water content, that will increase shelf life. That is a thumb rule. So when we are producing any varieties and we want to increase the shelf life, we have to concentrate on the dry matter as well as the water content. So that can be increase the shelf life of that particular product. Delaying leaf senescence, particularly in leafy vegetable, that is an important target for breeding of leafy vegetables. Because even one day, like we have a coriander leaf, we have amaranthus leaf, we have a spinach leaf, within one day that are unmarketable. So we have to be how we have can delay the leaf senescence. Lot of genes are there. Accordingly, we have to decide our breeding goals. Onion and tomato cultivar with longer shelf lives, melon and watermelon cultivar with higher sugar content and firmer flesh, etc. have been already developed. Cultivar having better storage characteristics, including resistant to storage fungi and pest and free from physiological disorder, need to be developed. We have to be, when we are putting our particular product in the storage conditions, so we have to be studied whether they are suitable for more days of storage or their storage life or less. So this type of study also, when we are breeding, particularly for post-harvest and export, then we have to consider it. Introduction of anti-ripening genes. Already we have discussed in the previous slides, read and nor that has been transferred in the tomato that are used in the delayed ripening. But actually this technology is not very popular in tomato. Therefore, generally we are not using. So this type of research, what we are discussing, particularly for post-harvest and export, they need lot of funding. Adequate funding is required, as well as improved linkage among the breeder, nutritionist, and health sector expert. If we do not have the multidisciplinary team, it is very difficult to breed the variety which is suitable for the post-harvest and export. Breeding for processing and value addition. Next, this is a part of that also. So processing and value addition of vegetables crops in India is less than 5%. Although we are second largest producer of vegetable crops. If we can increase our processing and value addition near about 10 to 15%, then we can minimize our post-harvest loss up to 5%. So we can save a lot of money, lot of time, lot of nutrition also. If we calculate in terms of nutrition, what we have due to these post-harvest losses, it is huge money. So we have to increase our processing and value addition, particularly in vegetable crops. The value of one processed product, gherkins, that has been exported from India is more than 1,200 crores. And approximately 500 farmers are involved to produce the gherkin, and it is a 100% exportable commodity. Particularly in case of these our gherkins, that here you can see the figures. It has a lot of processing value, and in the help of with the model of buyback systems, particularly Karnataka is the #1, particularly for processing of gherkins. So in the horticulture costs, we are getting maximum export value from these exporting the Gharke. 70 to 80% demand of natural edible color of the world is fulfilled by India, and 60% fulfilled by the Chile itself. Out of that 70 to 80%, what we are exporting to other countries, 60% of natural color we are extracting from the Chile, and remaining from turmeric and marigold. One variety that has been developed, Kasi Sinduri, variety of Chile, that having the ester value more than 200 units is more suitable for the color extraction. So here we have to develop the variety which have good in oleoresin, which has good in capsaicin, which have the better ester value. So based on our parameters, we have decided our product. So one example, we can say that two varieties that has been developed in Asgard, three varieties, that is Kasi Ujjwal, Kasi Dhaval, and Kasi Dhaval and Kasi Ujjwal. These two varieties that has been developed in Asgard. So these are the some parameters, particularly when PETA industry, they need high pulp recovery, they need high content of dry matter, they need less crude fiber, they need high flesh diameter, less seed with linear arrangement of the fruits, shape and size of the fruits, oblong and big size fruits. The fruits weight should be more than 7 kg. Then these PETA industry, they are accepting our Asgard fruit. Otherwise, they are not interested to take our fruits. In Nagpur, now Haldiram, they need near about 10 tons Asgard fruits per day, but their demand is that any Asgard variety, if they had fruit less than 7 kg, they are not accepting. That any variety, they have these parameters, what we have enumerated here, and these parameters, what we have decided, that is based on the help of processing industry, and based on these processing industry parameters, these two varieties that has been released and notified by Government of India for the PETA industry. In tomato, Arka Asis and Arka Huti, in point and grade variety Kasi Amulya, that were released and notified for the processing purpose, particularly these for the sauce and ketchup, and these Kasi Amulya for the pointed guard sweets. Generally, we are having the sweet preparation in some places. It has less seed, particularly in fruits. So therefore, it is mostly preferred. Several value-added products have been developed at IIVR, like bitter gourd chips, green chili powder, dried carrot, okra pointed gourd, based on the osmo air drying principles. Protein-rich instant corn vegetable soup mix, instant bottle gourd kheer mix, and moringa soup were also developed and are ready to eat. Breeding objective for every product are different, even in the same crops. If you are working for processing and value addition, suppose for any crops, you can take the example particularly for these chips, particularly bitter gourd. If you are developing for chips, then quality parameters will be different. If you are having the chips, powder, you are developing the bitter gourd powder, then your quality parameter will be different. So each objective, based on the objective of our value added or processing product, our product parameters will be changed. Processing traits of different value added product in different vegetable crops need to be redefined. Therefore, we have to be very cautious for that. Both breeder and food technologists, here also this is a multidisciplinary work. Both breeder and food technologists have to work together, and screening study is required to get better variety in the lines. Here some products I would like to show you. This is the osmo dried cooker bits vegetable, particularly bitter gourd, ivy gourd, pointed gourd. Similarly, this is the product that has been prepared from the potato. These are the maida free. This is the from potato flour that has been, and this is the fasting friendly also, made from whole potato. There is no wheat flour has been used. So that is goodness for the candied fruits and rich taste butter made from whole potato and kodo millets, that is very rich in fiber, mineral, protein, and antioxidant rich. Similarly, potato podgi and semolina, that has been also prepared from the potato, whole potato itself. So that is made from the whole potato, and these are the very high fiber product and gluten free. Generally for wheat flour, we are having that these have the gluten, and some particularly that gluten has allergic problem with some persons. But these potato, don't have any gluten. Therefore, we are calling it as gluten free, and this is suitable for halwa. You can make the upama, you can make the chilla. Lot of product we can make using this product. So for this also we have to decide our parameters, what type of rates we require to get the more recovery of this type of product. This is the Biocom fried technology, a biofortified sweet potato, two chips that has been prepared, two type of chips. One is, you can see, this is the from Blue Krishna variety, and another is from Blue Sona variety. And these chips, they are providing 6.81 milligram beta carotene. That is full recommended dose of children and pregnant mothers, and 57.44 milligram anthocyanin per 100 gram of chips. So this is the full of, we can say, nutrition. So these type of product we have to decide. So when we have to develop the biofortified variety that are rich in beta carotene, these are the some breeding aspects we have discussed, and what opportunity we have, particularly in our country, for this type of attempting this type of breeding program. So we are rich in genetic diversity, number one. So this genetic diversity we can utilize in our breeding program. Here you can see there's some tomato and diversity in brinjal. Also we can see lot of wild relatives we are having in our brinjal. We have the lot of genetic diversity, lot of wild species with us. So that can be utilized for our this type of program, which we this type of breeding objectives what we have discussed in our previous slides. Similarly, variability in chili, you can see we have the different color, different shape, even different in pungency also. We have a very high pungent line, we have very low pungent line or zero pungent line in our chili program. So these type of variability we can utilize. Similarly, in okra also we have lot of wild species as well as lot of variability in our cultivated species also, and that has been very successfully, that gene particularly for yellow vein mosaic virus and nasal leaf curve virus gene that has been transferred from wild to cultivated species in case of okra. Similarly, in cucurbits we can see lot of indigenous cucurbits we have with us, and we can say that these are the treasures of the several genes. It may be quality, it may be abiotic, it may be biotic, and not only in India, several other countries they have utilized our particularly cucurbits sunflower, and now they have the lot of resistant varieties, particularly in case of melons, indigenous melons we have in our bitter gourd we have. So in cauliflower, lot of variability in color, shape, and temperate to tropical we have. So that type of variability we can, these are the opportunity what we have. We can use this type of opportunity, and we can have our breeding program accordingly we can design. Similarly, in morphological diversity, you can see among the carrots and radish, we have white type, we have purple type, we have black type, and this variability we can use for our development of nutritional rich varieties as well as the nutraceutical varieties particularly. And other opportunities, we have the utilization of wild relatives. We have to be, wild relatives are major source of resistance, as all we know. That is not only for the disease, insects, this is also for the abiotic stress tolerance, particularly high temperature, heat, moisture stress, that become more important in future. Improved technology, especially genomic assisted breeding, that can be facilitate to integration of the favorable traits from wild species into cultivated. And other opportunities are public sector to work on more crops. We have Private sectors, they are concentrating only the crops which have heterotic value. They are concentrating hardly 12 to 13 vegetable crops, which are very low volume and have heterotic effect, and based on their business strategy. So here we have this public sector, they have a lot of scope. We can work more than 100 crops. So this is also an opportunity for us. We have a wide range of crops with us, and we can, these breeders, whether this is minor crops or major crops or underexploited crop, we can work. Breeder has a lot of scope. And other opportunity what we have, that is well-developed infrastructure. We have largest all India coordinated network project in the country, including lot of centers in ICR, lot of each and every university, almost they have the vegetable science department. So therefore, we have infrastructure with us, and not in one place, that is in different location of the country. So location specific technology, location specific varieties, location specific germplasm we can conserve, we can utilize. So these are the some opportunities which we have to utilize. A new area of breeding varieties for protected cultivations, breeding variety for processing, lot of area we have lead. Breeding variety for export quality, already we have discussed almost all aspects. So these are the new area. Generally, till date, we are only focusing on the yield parameters. Now our focus has been changed. Now we are developing the biofortified variety, we are developing the processing variety, we are developing the variety for export purpose. So these are the new area. And breeding for protected cultivation also one of the important. We don't have any variety particularly in cucumber and tomato or capsicum. So we can concentrate. Some institutions, they have developed few varieties particularly in cucumber, but still we have to be compete with the private sector particularly for protected cultivation varieties. And good market demand. Huge populations we have, more than 135 billion consumer is our country we have. So demand of vegetables is going to be increased by 3 to 4% annually. So need not to worry, always market is there. So what are the way forward? We have discussed what should be our objective, what is the opportunity we have, what is the way forward, how we can go for this breeding program. So we have to do the pre-breeding. Pre-breeding means before releasing the variety, we have to develop the trait-specific lines with the help of genomics and bioinformatics for the abiotic stress tolerance and biotic stress tolerance and other traits also. That will improve the precision and quick results. And speed breeding also, because if we are targeting any product particularly, it is taking more than 7 years, 10 years, sometimes it is 12 years when we are pyramiding many genes. So if we can take the 4 to 5 generation in a year, and application of DS technology also we can, if we can put the DS technology, otherwise the speed breeding facility we can use. So we can minimize, if we can have the 4 to 5 generation in a single year, and if we have a DS technology, so we can minimize the advancement of generation. We are getting the homozygous line in the just after one generation. So it will help to develop new varieties within 2 to 3 years. So these are the way forward for us. An application of molecular assisted breeding tools to get the accurate and quick results, and utilization of new breeding techniques. Sorry. Application of the new breeding techniques. These new breeding techniques involve both genome editing and non-genome editing techniques. So for that, we have to use these new breeding techniques. And there are 3 gene editing new breeding techniques. Most widely now used are the CRISPR-Cas9 is the newest and most powerful of the gene editing technology. Others are also, but generally they are least preferred, like TALEN and GFN. And some other non-gene editing new breeding techniques are there. That is RNAi, mostly used to develop the viral disease resistance. Agroinfiltration, that is used to induce transgene expression in plant or even in culture in plant cell. Epigenetic approach we can use, such as RNA-directed DNA methylation are being explored to manipulate plant DNA without permanently changing it. Site-directed mutagenesis also we can use and grafting non-GM sign on GM root stock. Also, that particular aspects we can utilize in our breeding program. And reverse breeding, we have a lot of material with us, whether we can go for some lot of hybrids we have, lot of private sector hybrids we have, whether we can break it and we can proceed for the reverse breeding, so we can have the lot of gene with us. And root stock breeding, earlier we have discussed like bacterial wilt resistant and other. So we have to emphasize and we have to give the lot of emphasis, particularly our root stock breeding. We have to it is generally we are not working on this, but now some program that has been started, particularly soil-borne diseases and moisture stress. That is two most important aspects that can be covered under root stock breeding. Continuous education and training is also very important. Continuous training should be available for vegetable breeders because the changing of technology is very fast. If we do not have a training, particularly for our vegetable breeders or vegetable workers throughout their careers, at least they can learn the new techniques. So training is very important aspects. Continuous education, lot of new technologies are coming, new breeding technology, CRISPR-Cas9. Even when we were studying, we don't know CRISPR. Even marker selections, we were not familiar when we were studying that time in 1997, 98. So by the training and by the education, we got familiar of this type of new technology. Public and private partnership. Strong coordination is required to fulfill the desired objective. Contribution of private sector, vegetable industries are commendable. We have to have a collaboration program with the private sectors because they are also working for our nations and they are working for our farmers. We can collaborate, we can check out some program. So our results may be more robust as compared to if we are working in isolation. And frequent revision of syllabus. Why I'm saying that frequent revision of syllabus? The changes happening in new breeding techniques, technology need to be added very frequently in our syllabus. That may provide the clear path for obtaining knowledge and experience and skill for the students. Because if we are changing our syllabus after 5 years, after 6 years, within that time, we can get a lot of new technologies are coming. So we have to be in our study program that new techniques we have to be, and it is only possible when we are frequently changing our syllabus. So that may also be considered. And for our conclusion, we have summarized how we can go for our breeding program, particularly when meeting the demand of producers, consumer, industry, exporters, end user. So these are the lot of methodology what we have, including classical breeding, so we can breed for higher yield, better quality, appearance, taste and flavor, wider adaptability, off-season suitability, abiotic tolerance, suitability to protected structure, low chemical residue, biotic stress tolerance, and specialty traits related to industrial demand and exports. So and other vegetables crop improvement powered through the plants that contribute to healthful diet and enhance quality of life for people around the world. Investors, public and private both, here they have to be turn their attention to enhance the funding for vegetable sector. Because if we see we are working a lot of crops, if we are not getting the fund particularly, so it is very difficult to do the new research, particularly these cutting edge research. It is very difficult. That will allow the farmers to compete with their products on the world market. Only then the silent vegetable revolution currently underway benefit a poor farmers, consumer, and industry. With this, I thanks to the organizer for giving me a chance to share my few ideas with all of you. I hope I may have served the purpose of this training program. With this, I thank all the audience who joined this online training programs and given their times for their patience hearing. Thank you very much, one and all.
बहुत बहुत धन्यवाद सर। स्मिता जी।
Thank you so much, sir. Thank you so much for this knowledge enhancing session. And the points you covered with this session, like the market demand and the consumer preference, this is the most boosting aspect of this training session. Hope to have you, sir, with in near future, like these more valuable sessions with you in the near future with our university. And I hope the participants who joined with us, they also get the scenario of vegetable breeding and the the demand-driven vegetable breeding challenges and opportunities, which you suggest the way forward and the conclusion, the opportunities and the challenges you suggested. I hope these points will help everyone who joined the session.
बहुत बहुत धन्यवाद सर। बड़ा अच्छा लगा आपके इस व्याख्यान हेतु। एक व्यक्ति पूछने की कुछ मनसा रखता है। हाँ, आप चैट बॉक्स में लिख सकते हैं यदि किसी का कुछ वैलिड क्वेश्चन है।
चैट बॉक्स आप हमको शेयर भी कर सकते हैं बाद में। I can reply if they put their mail address, so we can reply. Otherwise, my mail address is sudhakar@gmail.com. They can directly put their questions with us, no problem.
बहुत बढ़िया, ये बहुत अच्छा रहा सर। यदि किसी को कोई डाउट है तो आप सर को डायरेक्ट ईमेल भी कर सकते हो, सर फ्री पीरियड में उसका रिप्लाई कर देंगे। सर का एक अनदर एंगेजमेंट है 8 बजे, तो सर को जाना होगा। तो यदि किसी का कोई डाउट है तो आप ईमेल के द्वारा उनसे पूछ सकते हैं।
If 1 or 2 questions we can take.
ज्यादातर सर रिप्लाई आ रहा है, नाइस प्रेजेंटेशन, एक्स्ट्रा ऑर्डिनरी प्रेजेंटेशन, थैंक यू सो मच सर फॉर दिस इंफॉर्मेटिव प्रेजेंटेशन। ज्यादातर तारीफें आ रही है सर। मतलब सेल्फ एक्सप्लेनेटरी लेक्चर था, इसमें कुछ था ही नहीं ऐसा डाउट। कुछ लोग कह रहे हैं कैन यू शेयर दिस पीपीटी सर, वेरी वैल्यूएबल पीपीटी, कैन यू शेयर दिस पीपीटी?
Yeah, why not? I will share with you. You can share with your audience.
Okay, thank you sir, thank you.
Yeah. Thank you very much.
जी सर, तो सर आप कंक्लूड करते हैं?
Yeah.
जी, थैंक यू।
Thank you. Now we can leave.
Yes sir, please.
Thank you very much. Thank you very much, Ankur.